All right, get ready to dive into something massive. I mean, like literally huge. We're going to be exploring the future of space exploration. Specifically, how scientists are using simulated universes to get ready for all the crazy amounts of data we're going to get from NASA's Roman Space Telescope.
Yeah.
You guys sent in some super interesting articles about this. One about the OpenUniverse project and the other about the Roman telescope itself. And we are ready to break it all down.
Yeah, this is some pretty mind-blowing stuff.
So, okay, simulated universes. That sounds like, I don't know, something out of a sci-fi movie.
Yeah, it kind of does, but...
It's a real thing, and it's called OpenUniverse.
Okay, so first things first. What is this OpenUniverse thing?
So basically, scientists are using supercomputers to create, like, millions of simulated images of space. And it covers this huge area. It's like, oh, man, it's like 300 full moons worth of sky.
Whoa, 300 full moons.
Yeah, and it spans billions of years of cosmic time.
Okay, so that's a lot of data.
Oh, yeah.
But why even do it? Why create a fake universe?
Well, that's where the Roman telescope comes in.
So this telescope is set to launch pretty soon, actually, by May 2027. And it's going to be collecting an insane amount of data.
Okay.
Way more than any telescope we've ever had.
So OpenUniverse is like, what? Practice.
Yeah, exactly. It's like a dress rehearsal for all that data.
So they're getting ready for this, like, tsunami of information.
Right. Imagine trying to find something super specific, like a rare supernova, in a data set the size of, I don't know, the Library of Congress.
Yeah.
It's a lot. So OpenUniverse is helping them develop the tools, specifically these machine learning algorithms, that can sift through all that data.
Okay.
So we can actually find those needles in the cosmic haystack.
Cool.
And they're using it to test out their analysis methods, too. So when the real data comes in, they're ready to go.
Well, that makes sense. So they're like
Yeah.
making a map before they go on this big expedition. Okay, so we've got this super powerful telescope, it's Roman, that's going to give us a way clearer and deeper view of the universe. But it's also going to drown us in data. And that's where OpenUniverse comes in.
Yeah.
It helps us make sense of it all.
Yeah.
Okay. But what about the actual science? What can we learn from this simulated universe?
Well, OpenUniverse isn't just about managing data.
Okay.
It's a tool for actual scientific discoveries.
Oh, cool.
Like they're using it to study dark energy and dark matter.
Dark energy and dark matter. Always hear about those. But they're still kind of a mystery, aren't they?
Yeah, they definitely are.
Can you remind us what those even are and how OpenUniverse helps us study them?
Sure. So we know the universe is expanding, right? And
Yeah.
that expansion is actually speeding up.
Yeah.
But we don't know why. That's where dark energy comes in. It's this mysterious force that seems to be pushing everything apart,
Okay.
working against gravity,
I said, oh,
anti-gravity.
kind of.
And then there's dark matter, which we can't see directly, but we know it's there because of how it affects gravity. It's like this invisible scaffolding holding the universe together.
Wow.
So OpenUniverse lets scientists run all these simulations. They can tweak the properties of dark energy and dark matter and see how it affects the simulated universe.
Oh, wow.
It's like running experiments.
On the universe.
Yeah.
That's crazy. So by comparing the simulations with what they see with Roman, scientists can test their theories
Exactly.
about dark energy and dark matter.
Yeah, and maybe even come up with new ones.
That's so cool. I also read that they can make movies of exploding stars.
Yeah.
Supernovae in OpenUniverse.
That's one of the coolest parts.
That does sound pretty cool. But how did those movies actually help scientists?
Well, imagine being able to fast forward and rewind the life of a star,
Okay.
and you can see how it evolves over millions of years, and then watch it explode as a supernova.
Wow.
And these simulated movies aren't just pretty pictures. They give scientists this incredible tool to study all sorts of things.
God, what kind of things?
Well, for one, we can learn way more about the life cycles of stars,
Okay.
how different types of stars evolve, how they create heavy elements,
Okay.
and how they eventually die.
Interesting.
This helps us understand how galaxies themselves form and evolve.
Oh, that makes sense.
But it goes even beyond that.
Yeah, okay.
Supernovae play a huge role in how the universe expands.
Mm.
The light from those explosions
Mm.
can be used to measure cosmic distances and how fast the universe is expanding.
I see.
So by studying supernovae in OpenUniverse, scientists can refine those measurements and test different models of how the universe is expanding.
So these virtual explosions can teach us a lot about the real universe.
Exactly.
Mm.
And here's something else that's really cool.
Okay.
Scientists are using these simulated supernovae to build an early warning system.
Oh, like a supernova alert system.
Yeah, kinda.
That's wild.
They're training algorithms to spot specific patterns in the data, patterns that show a supernova is about to happen.
I see.
So when Roman sees those same patterns, astronomers will get an alert.
Oh, that's awesome.
So they can point their telescopes at the right spot, at the right time, and capture the supernova in action.
That is so cool. So, okay, we've covered a lot. OpenUniverse is this ridiculously detailed and vast simulation that's helping us get ready for all the data from the Roman telescope. It's helping us develop new tools and techniques for analyzing all that data. And it's a powerful tool for making new scientific discoveries about dark energy, dark matter, supernovae, and probably a ton of other stuff. It's like a cosmic playground for scientists.
Oh, it really is. It's incredible what they're doing.
Totally.
All this talk about simulations, it kind of makes you wonder.
About what?
What's the line between simulation and reality?
Oh.
Makes you think.
Right. Definitely. And it makes me even more excited to see what we discover with Roman. So we've talked about how OpenUniverse is prepping us for this data flood. But let's talk about the source of that flood, the Roman telescope itself. Right. What makes it so revolutionary?
Well, as we touched on earlier, Roman is going to be a massive leap forward in how we observe the universe. It's going to be capturing images with a field of view hundreds of times larger than Hubble's, which means it can survey vast areas of the sky way faster.
Enceladus is like looking at the universe through a drinking straw. Roman is like, I don't know, panoramic vision.
Yeah, that's a great way to put it. And like we said, it's not just about size. Roman will be observing in both infrared and optical wavelengths. So we'll get a way more complete picture of the universe than we've ever had before.
So we'll be seeing the universe in Technicolor, so to speak. But all this talk about data and simulations, sometimes it's easy to lose sight of the big picture. What are the big questions that scientists are hoping to answer using OpenUniverse and Roman?
That's a great question, and it gets at why we're so excited about these projects. Roman's going to help us understand dark energy and dark matter in much greater detail. We'll be able to study how galaxies change over billions of years. And map the distribution of matter throughout the universe. It's like having a time machine and a cosmic map all rolled into one.
You mentioned galaxy evolution. I've always been fascinated by that. How these giant collections of stars form and change over time. What kind of insights can Roman give us into that process?
Imagine being able to observe galaxies at different stages of their lives. From their early formation to when they're mature, Roman can do that.
Really?
By capturing light from galaxies that are billions of light years away. We're basically looking back in time, seeing how galaxies have changed throughout history.
So it's like having a photo album of the universe's childhood.
Exactly. And by looking at these baby pictures of galaxies, we can learn so much about how they formed, how they interacted with each other, and how the conditions in the early universe shaped the galaxies we see today.
That's amazing. So Roman will be a total game changer for understanding galaxy evolution. But what about the stuff we haven't even thought of yet? Those unexpected discoveries that always seem to come with new scientific instruments.
That's what I'm most excited about. Every time we launch a new telescope with better capabilities, we find things we never anticipated.
Really?
Things that challenge how we understand the universe. And I'm sure it'll be the same with Roman.
It's that sense of the unknown, the possibility of uncovering something truly groundbreaking. That makes all this so exciting.
Absolutely. And it's not just about the telescope itself. It's about how we're using data and simulations to totally change how we do science.
Could you explain that a bit more?
Sure. So in the past, astronomers would spend hours and hours looking at images, trying to figure out what they were seeing, trying to classify objects. It was a slow process.
That's a bit like trying to find a specific grain of sand on the beach.
Exactly. But now, with machine learning and simulations like OpenUniverse, we can automate a lot of that.
Oh, cool.
So astronomers can focus on the bigger questions.
It's like having a team of digital assistants working alongside astronomers, helping them sort through all the data and make new discoveries.
Exactly. And this data-driven approach is changing how we think about the universe.
How so?
Well, we have all these theories about how the universe works, right?
Right.
Based on what we know about physics and cosmology. But those theories are only as good as the data we have to support them.
So it's like having a blueprint, but you're not sure if it's accurate.
Exactly. But with Roman and OpenUniverse, we'll be able to compare our theoretical predictions with what we actually observe, if our theories are right. The simulations from OpenUniverse should match the real data from Roman.
But if they don't match?
That's where things get really interesting. It could mean our theories are incomplete. or even wrong. It could mean there are new laws of physics that we haven't discovered yet.
So it's like a
Yeah.
cosmic truth test,
Yeah.
comparing our ideas with what the universe is actually like.
Exactly. And that's why projects like Roman and OpenUniverse are so important. They're pushing the limits of what we know about the universe and making us confront the limits of our own understanding.
It's crazy to think about. We're talking about simulating entire universes and building telescopes that can see billions of years into the past.
It really is mind-boggling.
It is.
And it shows how incredible human ingenuity is.
Yeah.
And our endless curiosity about the cosmos.
Speaking of curiosity, you mentioned earlier that OpenUniverse brings up some pretty deep questions about the nature of reality.
Yeah.
Can you talk about that a bit more?
Of course. As we create these increasingly realistic simulations of the universe, it's hard to ignore the question, what's the difference between a simulation and reality? And could there be simulated universes out there that don't even know they're not the real thing?
Wow. That's getting into some serious philosophical territory.
It is, but it's a question worth thinking about, especially as our simulations get more and more advanced.
So we're not just exploring space. We're exploring the very nature of existence.
Exactly.
That's pretty amazing.
It is. What makes this all so exciting is that we're not just collecting data. We're wrestling with some of the biggest questions humanity has ever asked.
I don't know about you, but I'm ready to dive even deeper into this rabbit hole.
Me too. Let's do it.
It's incredible to think that we're not only exploring this vastness of space, but also the very nature of reality itself.
Yeah, it really shows how connected science and philosophy can be.
Totally. And, thinking about all this makes me appreciate all the scientists and engineers working on these projects.
Oh, yeah.
It takes a special kind of brilliance and dedication to do this, to simulate a whole universe, or build a telescope that can see billions of years into the past.
It really does. It reminds you that human ingenuity has no limits. We're always pushing the boundaries of what's possible because we want to understand the universe and our place in it.
Speaking of curiosity, I'm sure our listeners are eager to learn more about OpenUniverse and the Roman telescope. Where can they go to explore these topics further?
Well, NASA's website is a great place to start. They've got a ton of information about the Roman Space Telescope. Stunning images, videos, even interactive features. You can also find detailed articles about OpenUniverse on websites like SciTech Daily and FIS.org.
Okay.
Those articles go deeper into the technical stuff and the scientific discoveries it's making possible.
Cool. And for our listeners who prefer to learn visually, there are some great documentaries and videos online that explore the science behind these projects and the people who are making them happen.
Absolutely. And don't forget to check out the show notes for this episode. We'll include links to everything we've mentioned, plus some extra reading material for those who want to go even deeper.
Awesome. So as we wrap up this deep dive, what's the one thing you want our listeners to remember?
I think the biggest takeaway is that we're living in a truly amazing time for astronomy, with powerful new telescopes like Roman and innovative tools like OpenUniverse. We're at the beginning of a new era of discovery, an era where we'll be able to answer some of the most fundamental questions about the universe and our place in it.
It reminds us that there's still so much out there to explore, and that the journey of scientific discovery is far from over.
So keep looking up, keep asking questions, and never lose your sense of wonder.
Beautifully said. And on that note, we'd like to thank you for joining us on this deep dive into the world of simulated universes and the incredible power of the Roman Space Telescope. We hope you've enjoyed the journey, and we'll see you next time for another adventure in knowledge.
Yeah, it really does.
It does. Makes me even more excited to see what we learned from the Roman telescope itself, like we talked about OpenUniverse prepping us for this data flood.
Let's talk about the source of the flood, the Roman telescope. What makes it so revolutionary? Well, as we mentioned, Roman is going to be this huge step forward in how we look at the universe. It's going to be taking pictures with a field of view that's hundreds of times bigger than Hubble's.
Wow.
So it can map huge areas of the sky way faster.
Okay, so if Hubble's like looking at the universe through a straw,
Yeah.
Roman's like, I don't know, have this panoramic view.
Yeah, that's a great way to put it. And like we said earlier, it's not just the size. Roman can also see in both infrared and optical wavelengths. So we'll get a much more complete picture of the universe than we've ever had.
It's like we'll be seeing the universe in Technicolor, so to speak. But with all this talk about data and simulations, it's easy to forget the big picture. What are the big questions scientists are hoping to answer with all this? With OpenUniverse and Roman?
That's a great question. It gets at why we're so excited about these projects. Roman's going to help us understand dark energy and dark matter much better than we do now.
Okay.
We'll be able to study how galaxies change over billions of years and map out how matter is spread throughout the universe. It's like having a time machine and a cosmic map all in one.
You mentioned galaxy evolution. That's always been fascinating to me, how these huge groups of stars form and change over time. What can Roman tell us about that?
Well, imagine being able to see galaxies at different points in their lives, like from their early formation, all the way to when they're mature. Roman can do that by capturing light from galaxies that are billions of light years away. We're essentially looking back in time, seeing how galaxies have changed throughout history.
It's like a photo album of the universe's childhood.
Exactly. And by studying these baby pictures of galaxies, we can learn so much about how they were born, how they interacted with each other, and how things in the early universe shaped the galaxies we see today.
That's incredible. So Roman is going to be huge for understanding how galaxies evolve. But what about all the things we haven't even thought of yet? All the unexpected discoveries, the kind that always seem to happen with new telescopes.
That's what I'm most excited about. Every time we launch a new telescope that's more powerful, we always find things we didn't expect.
Really?
Things that make us rethink how we understand the universe.
Oh.
And I'm sure it'll be the same with Roman.
It's that sense of the unknown, that possibility of finding something totally groundbreaking.
Yeah.
That's what makes this so thrilling.
Absolutely. And it's not just about the telescope. It's about how we're using data and simulations to completely change how we do science.
Can you talk a little bit more about that?
Sure. In the past, astronomers would spend hours and hours looking at images, trying to figure out what they were looking at, and classify objects. It took forever.
Sounds like trying to find a specific grain of sand on the beach.
Exactly. But now, with machine learning and simulations like OpenUniverse, we can automate a lot of that work.
Oh, cool.
So astronomers can focus on the big questions.
It's like they have a bunch of digital assistants working with them to help them sort through the data and make new discoveries.
Precisely. And this approach, this data-driven approach, is changing how we think about the universe. Well, we have all these theories about how the universe works, and they're based on our understanding of physics and cosmology. But those theories are only as good as the data we have.
So it's like having a blueprint.
Yeah.
But you're not sure if it's right.
Exactly. But with Roman and OpenUniverse, we can compare what our theories predict to what we actually observe if our theories are right. The simulations from OpenUniverse should match the real data from Roman.
But what if they don't match?
That's where it gets interesting.
Hey.
It could mean our theories are incomplete or even wrong. It could mean there are new laws of physics out there that we don't even know about.
That's like a test of what we think we know.
Yeah.
Comparing our ideas with how the universe actually is.
Exactly. And that's why Roman and OpenUniverse are so important. They're pushing the boundaries of what we know and making us face the limits of what we understand.
It's mind-blowing to think about. We're simulating entire universes and building telescopes that can see billions of years into the past.
It is amazing.
It is.
It really shows you how clever humans are and how curious we are about space.
Speaking of curiosity, earlier you said OpenUniverse brings up some deep questions about the nature of reality.
Oh, yeah.
Can you talk about that a bit more?
Sure. As we make these simulations of the universe and they get more and more realistic, it's hard not to ask, what's the difference between a simulation and reality? And could there be simulated universes out there that don't even know they're not real?
Whoa, that's getting pretty philosophical.
It is, but it's a question we should be thinking about, especially as our simulations get more advanced.
So it's not just about exploring space, it's about exploring what it means to exist.
Exactly.
That's incredible.
It is, and that's what's so cool about this. We're not just gathering data. We're grappling with some of the biggest questions humans have ever asked.
I don't know about you, but I'm ready to go deeper down this rabbit hole.
Me too. Let's go. It really is.
It really highlights how much science and philosophy are connected. And, it makes you appreciate all the work that goes into projects like this, the scientists, the engineers.
Yeah.
It takes serious brains and dedication to pull this off, like simulating a whole universe or building a telescope that can see billions of years into the past.
It really does. It shows you that humans can do anything.
Absolutely.
We're always pushing the limits of what's possible, always trying to learn more about the universe and where we fit into it all.
Speaking of learning, I bet our listeners want to know more about OpenUniverse and the Roman telescope. Where can they go to dig deeper?
Well, NASA's website's a great place to start. They have a ton of info about the Roman Space Telescope.
Okay.
Amazing pictures, videos, even interactive stuff. And for OpenUniverse, you can check out websites like SciTech Daily and FIS.org.
Okay.
They have articles that get into the technical details and the discoveries it's helping us make.
Cool. And for our listeners who like to learn by watching, there are some really good documentaries and videos online that explore the science behind these projects and the people who are making them happen.
Oh, yeah. And don't forget to check the show notes for this episode. We'll link to all the stuff we mentioned, plus some extra reading if you want to go even deeper.
Perfect. So as we wrap up this deep dive, what's the one big takeaway you want our listeners to leave with?
I think the most important thing is we're living in an incredible time for astronomy, with powerful new telescopes like Roman and amazing tools like OpenUniverse. We're entering this new era of discovery, where we can finally answer some of the biggest questions about the universe and our place in it.
It's a good reminder that there's still so much out there to explore, and that the journey of scientific discovery is far from over.
So keep looking up, keep asking questions, and never lose that sense of wonder.
Beautifully said. And on that note, we want to thank you all for joining us on this deep dive into simulated universes and the incredible Roman Space Telescope. We hope you enjoy the journey, and we'll see you next time for another adventure in knowledge.